All right, this is lesson 432, part A. We're going to learn how to simplify radical expressions. A lot of what we do, if you think back to just simplifying algebraic expressions, it'll be somewhat the same. And a couple of terms you're going to need to know here. Of course, this is any expression that has a root in it like this. A square root is called a radical expression. So I'll just give an example like 2a. That's a radical expression. And we'll run across this again, but I might use these terms, so I want you to know what I'm talking about. And the number that's underneath the radical sign, this is called the radical sign. The number underneath is called a radicand. A and D, radicand. All right. So what we want to do is we want to see if we can't use some mathematics to help us simplify radical expressions. So we want to look at what we can do with radicals and what we can't do. And this first one is what we're trying to decide is whether or not we can add radical expressions together separately and then put the radical sign over them. In other words, I'll just give you a quick simple example here. Let's say we have the square root of 4 plus the square root of 9. Is that the same as the square root of 13? Can we simplify it that way? We're going to find out by looking at some problems and just deciding for ourselves whether or not we think we can do that. So we're going to start here with this little table, and we have the two different expressions. And the first two values we're going to use for x and y are 0 and 0. So on this first one, we're going to do square root of 0 plus the square root of 0. And the square root of 0 is 0, so it's really just 0 plus 0, which is 0. And then we're going to combine them together, add them together first under the radical sign. And that equals the square root of 0, which is 0. So given the values 0 and 0, it seems like we get exactly the same answer for the square root of 0 plus the square root of 0, or if we do the square root of the quantity 0 plus 0. They seem to be the same for that one. But that's not enough to prove that we can always do it. So let's try another one. So in the second one here, we're going to do the square root of 4 plus the square root of 4. And that's equal to 2 plus 2, which is 4. And then now we're going to add 4 plus 4 first under the radical sign. And that's 8. And then we have to think, is the square root of 8 equal to 4? I don't think it is. The square root of 16 is 4. The square root of 8, and we can use our calculator to figure this out, but it's actually equal to approximately 2.83. And I'll show you how you can do that on your calculator. Okay, on your calculator, the two expressions we just did. So we did square root of 4. Now, be careful when you do this. You have to close off the parentheses to make sure it just does that. And then we did plus the square root of 4. And close off the parentheses again and find out what that equals. And then the other way we want to do it is we wanted to add 4 plus 4 first. In order to do that, we're not going to close the parenthesis off until after we've added 4 plus 4. Then close the parenthesis, press enter, and there is an irrational number. 2.82, and so that's how you use your calculator to do that. So when we did the square root of 4 plus the square root of 4 separately, we got 4, but when we combine them together, we got 2.83. At this point, that's a counterexample that shows this will never work. We really don't have to continue here, but just in case our math is suspect, we might go ahead and try another one here. So let's try this next one. It says we want to do the square root of 36 plus the square root of 16. And then we want to do them together underneath the radical sign. And if we do them separately, and some of these we can do in our head, square root of 36 is 6, square root of 16 is 4, and 6 plus 4 is 10, so that's 10. The square root of 36 plus 16, I think I'm going to use my calculator to help me do that. So square root of 36 plus 16, and then close the parenthesis and press enter, and 7.2, again, an irrational number. It's about 7.2. So that's our second problem where we did not get the same thing. So I think I'm ready to make a conjecture here. We have a couple counterexamples. I'm going to say that the square root of x plus the square root of y is not equal to the square root of x plus y under the radical sign like that, unless the only example where it did work is when x and y are both 0. All right, so let's continue here. Let's try this one. This one we're trying to see if it works for multiplication. Can we multiply x times y underneath the radicand? Would that be the same as multiplying the square root of x times the square root of y? So let's try a few problems here, see if it works or see if it doesn't work. So in this first one, we're just going to do the square root of 0 times the square root of 0, and that's 0 times 0, which is 0. And then we're going to put it all under the parenthesis, under the square root symbol. And 0 times 0, do that first now, that's 0. And the square root of 0 is 0. So it works for that one. All right, it's not enough that it works for one, though. We need to try a couple. All right, so let's try this next one. So we want to know if this is true, the square root of 5 times the square root of 5. Is that equal to the square root of 5 times 5? Well, I'm going to do the second one first. Square root of 5 times 5, that's the square root of 25, and I know that the square root of 25 is equal to 5. So I'm going to put that there. And this other one here is the square root of 5 times the square root of 5. We can use our calculator for that one. The square root of 5. Again, we've got to be careful with the parentheses here. When I want to do the square root of 5 times the square root of 5, I need to close off my parenthesis like that and then do times the square root of 5 again. Some of you are thinking that you know the answer, I think. And it equals 5, because we're just taking the square root of a number, which undoes a square, and then we're squaring it, so we just end up with the radicand for our answer. So we get 5 in both cases. Let's try another one here. So the square root of 9 times the square root of 25, is that equal to, if I do 9 times 25 first and then take the square root of it? Well, square root of 9 is 3, square root of 25 is 5, so that's 15. I know that's 15 for sure. Now, 9 times 25 is 225. And if I go to the calculator, I actually know this one, but some of you may not. But the square root of 225 is equal to 15. So, once again, we get exactly the same answer. A lot of times I'll just do 3 in order to convince myself if it's going to work for 3 of them, it's probably going to work for all of them. So the rest of the parts here we can fill in, but my conjecture is that this will always be true, that the square root of x times the square root of y is equal to, I can multiply those two radicands together first, and I get the same result. And I think that's true for all numbers. Let's say all positive, all numbers greater than 0. Because we know that when you have negative numbers, you can't even take the square root of those, so we have to be a little bit careful with that. All right. Okay, I'm gonna let you do these two and decide for yourself which of these you think work and which ones you don't think work. And that's going to be part one. And part two, I'm going to show you how to do some simplifying by using some of those rules. So I'm going to stop here.